This is Mr. Beck Does Your Homework, AP Physics homework number 5.2, question number 5. A block of mass 14.7 kilograms slides from rest down a frictionless 40.1 degree incline and is stopped by a strong spring with a spring constant 30,100 newtons per meter. The block slides 3.02 meters from the point of release to the point where it comes to rest against the spring. So I've got an incline, I've got an angle of 40.1 degrees. I've got a block that starts from rest and winds up sliding down the incline until it comes to rest against the spring, and it compresses the spring so that at the end the block is here compressed against the spring, and that block is again at rest. So, and it compresses the spring some distance, and that's when it looks for, what it's looking for is what is this distance that the spring is compressed. So at this point, it can fall, so it's got some potential energy. At this point, the spring is all compressed, so it's got some spring potential energy. I'm looking for this distance. I know that this distance that it slides is going to be 3.02 meters from top to bottom. So what I need is some sort of conservation of energy here. Up here, it's got some potential energy due to gravity. Down here, it's got some potential energy due to the spring. So what I need is up here, the potential energy of gravity is going to here, the potential energy stored in the spring. So I've got my mgh, my potential energy of gravity, is going to equal 1/2 kx squared. Now let's see what of this I know. I know the mass is 14.7 kilograms. I know the incline is 40.1 degrees. That's interesting. I know gravity is 9.8 meters per second squared. And I know 3.02 meters, but that is not my height. My height is going to be how much this height is up here. So my height is going to be this component of 3.02 meters. So my height is going to be 3.02 times, let's see, that's 40.1 degrees. That's the opposite, so that is the sine of 40.1 degrees. That's going to be my height that it changes. I know then that that's going to be 1/2 kx squared, so that's my mgh. Is going to be 14.7, 9.8, and 3.02 sine of 40.1 degrees. That's going to equal 1/2. My k is 30,100. And my x, well, I don't have to worry about the trig in the x because it's actually on the angle that I'm worried about. So I want to know what this distance is. Well, that's just going to be x, and so that's fine to solve for, kx squared. So this was the trick here, is knowing that the height change is going to be 3.02 times the sine of that angle. And so with this, you can solve for the distance stretched or compressed.